Okay. So 2-5 is about perimeter and area on the coordinate plane. Okay, so let's start with definitions of what is perimeter.
Distance around.
Okay, so distance around the object. So this right here says the sum of the lengths of a polygon. Okay, so everybody knows what a polygon is, right? What does poly mean? Many. So an enclosed figure can have any amount of sides. Okay, so we are going to use the distance formula to find the perimeter around these polygons. Okay. Are you ready? Okay. So here's going to be the first example. That part in purple that you cannot read says to find the perimeter. Find the perimeter. Okay, of this given polygon. Okay, so the first thing I'm going to do is I'm going to draw it so we have a visual, because perhaps some of you guys are visual learners. It is not necessary to draw a picture of it, but perhaps is useful. So if I was going to plot point A, what directions would I go? -1, 4?
Left and then up.
Left 1, up 4, so here's point A. Okay, what about B?
Right and then
Right 4, up 4. There's B. Okay, C?
right.
Right 3, down 2, so there's C. D? What? Left and down, so there's D. And then E? Left 4, up 1. Okay, so what do we have right here, by the way? A house? Tis a pentagon, yeah, 5-sided figure. So we got 5-sides pentagon. All right, so we're going to start from A to B. Distance from A to B. Okay, now if I look at this just by the picture, we can count out the length from A to B because they're on a straight flat line. So what's the difference, or the distance, excuse me, from A to B? 5. Okay, so I'm going to save myself a little time and just count that one out. Let's go from B to C. Okay, so this time I'm going to use the distance formula from B to C. Okay, so distance formula goes 4 minus 3 squared plus 4 plus 2 squared. Everybody okay following that? Using our ordered pairs. So can we do mental work here? And do 1 plus 4 inside the square root? Yep. So we get the square root of 5. No? Disagree? Okay. Let me just go back then. Or 1 plus, no, I did that wrong. I did a minus. 1 plus 36. Good, I'm glad you guys are paying attention. I was just testing you.
Of course.
I'm glad you guys passed this time. So Yuri, how about 37? Okay, so moving C to D. Okay, so that one's going to be the change in x's, so 3 plus 1 squared. And then -2 plus 4 squared. Okay, so this time we're going to get 16 plus 4. No, 16, yeah, 16 plus 4, 20. Oh, you guys are making me double check myself. Okay, moving around, now we're going from D to E. So that's going to be -1 plus 4. And -4 minus 1 squared. So 9 plus 25. 9 plus 25? Okay, and then our last length goes from E back to A. So we're going to go -4 plus 1 squared. And then we got 1 minus 4 squared. Okay, and let's see, we got 9 plus 9. What?
Yeah, it's 9.
9 plus 9? -3. So 18, right? Don't feel bad, I make mistakes too. Did everybody agree with that one? 18? Okay. So now that I have the distance for each of the sides, what do I do to find the perimeter? Add them all together. Okay, so because I don't want you to leave your answer in square roots as a perimeter, because that would be slightly ridiculous. Okay, at this point I would let you use a calculator and come up with a decimal value for this. Okay, so you guys have a calculator close by, right?
Wait, what are we rounding to?
Let's round to 3. So the way I'm going to type this in is I'm going to type in the exact lengths that I found, and then I'll round at the very end. If you start rounding initially, you're going to get further and further away from the exact answer. Okay, so you always want to type in exact values if you have them. Okay, so you're going to hit 5 plus, everybody find the square root. So you have to hit second, and then it's like right above that log key. 37. And then you have to hit the right arrow to get out from underneath it. Plus square root 20 plus the square root 34 plus square root of 18. Okay, so what I'd like you to round to is 3 decimal places. Okay, so I'm going to use a big capital P. Perimeter of our polygon is 25.628. Did anybody else get that answer? 25.628. Anybody disagree, agree? Agree? Okay. So this becomes slightly tedious, right? In finding perimeter. It is not really a new concept. Do I need to do another example of this? Phew. Okay, good. Alright, so let's move to area. Let me squeeze this in a little bit. Okay, so I'm going to give you a second here to write down these area formulas because they are incredibly helpful. Okay, I think the 3 on the top are pretty obvious. At least they should be. But I would absolutely write them down. And do remember when they say height, what is very important about the height? What?
Base to top.
Base to height, but what has to be the kind of angle involved between the base and the height? 90. Okay, so this becomes a little bit more, let's go with fun. Is that somebody's watch in this room? It's Ruff's? Damn. Okay, so if you know that you have a specific shape, specifically like a rhombus, a kite, or a trapezoid, it's super easy to use those formulas as long as you are given that information. Okay, but sometimes it's easier to just break things into triangles and rectangles and just work within that criteria. Can I go ahead and move on? Okay, so you guys keep writing as I talk here. So question number 2 asks us to find the area of this given quadrilateral. Okay, so the first thing that they ask us to do is to graph it to see what it looks like. Now, when you're finding area, I think a visual is really important. Okay, finding the perimeter is a little bit straightforward. You're just kind of using a formula the whole time. But when you're dealing with area, you want to see what shapes you're dealing with. Okay, that helps you kind of make it a little bit easier in breaking down the piece. So I'm going to start by plotting these points. Okay, so for J, I have -4, -2, which is there. For K, I have 2, 1, which is there. For L, I would have 3, 4. And M is -3, 1. Okay, so at this point, I hope that you see the value in graphing. Okay, what does this look like to you? A what? Yeah, I would agree with a parallelogram. Okay, and I think just by looking at this graph, we can quickly make sure that it is in fact a parallelogram. How would I quickly make sure that this is in fact a parallelogram? Okay, I can quickly count out the slopes of these. Okay, so if I was going from, here, let me use a different color, from J to M, I would say, oh, it's got a rise 1, 2, 3, run 1, so this one has a slope of 3. And then from K to L, 1, 2, 3, run of 1, so the slope for that one is also 3, so we got one set of parallel lines. Okay, from M to L, I'd go 1, 2, 3, and then over 1, 2, 3, 4, 5, 6, so 3, 6. Which I could say is 1/2. And then from J to K is 1, 2, 3, 4, 3, and then 1, 2, 3, 4, 5, 6. 3, 6. Okay, so just by counting them out, I can prove that I do have, in fact, a parallelogram. Agreed? Okay, so at that point, I can go to my definitions and say, what is the area of a parallelogram? Base times height. Okay, and the important piece of this is that the base has to form a 90-degree angle. Okay, so we can go about this 2 ways. Let's decide what length is going to be our base. Okay, I'm going to go back and I'm going to undo my little tick mark so this isn't completely marked up. Okay, so what length should be our base? Pick a base. JK? Hot JK. Okay, so JK is going to be our base. So we need to figure out the height. Okay, so we found the JK slope to be 1/2, right? So 1/2. Okay, so if I have to create a 90-degree angle, what's the 90-degree slope going to be? The perpendicular, -2, right? Okay, so -2. So what I can do, so I know that the perpendicular slope is -2, right? So what I can do is off one of the given points, and I'm going to go off of K so that I go straight up, and I actually hit a line. If I go from K, there's not really a line above it, so I'm going to go from K. So I'm going to count out a slope of -2 until I hit the other line. Okay, so slope, by the way, if I go at -2, what are my 2 directions? Left and up, right? So left 2, up 1. Okay, so I'm going to go left 2, up 1. Did I hit the line? No. Okay, so then I'd have to go left 2, but you see what happened? Up 1. Up, oh yeah, I totally screwed that up, didn't I? Rise over run. That's what I get for listening. So up 2 over 1. Undo those tick marks. Rise over run. So I go up 2, up 1. So there, that nails right at that spot. Okay, so how am I going to find the height of that blue line? The distance formula. Okay, so I'm going to call that other point, I don't know, what? N. That feels good. Okay, and so we'll use distance formula from K to N. Okay, which by the way, N is exactly hitting at 1, 3, right? Okay, so we're gonna go 1 minus 2 squared plus 3 minus 1 squared. So that would give me 1 plus 4. Everybody agree that's the square root of 5? Everybody good with that? Yes, Asia?
You just use the Pythagorean. You already know this one.
Yeah, absolutely. Which the distance formula is technically the Pythagorean theorem, but you're just filling in like you're using lengths instead of points. So yeah, absolutely, it's exactly the same thing. Okay. All right. So now to find area. Oh, we still need the length of our base. Hold on, slow down. Okay, so our base length, so was JK. So from J to K, we go -4 minus 2 squared, and -2 minus 1 squared. So do we get 36 plus 9? 36, right? Plus 9, so 36 plus 9. 45. Okay, good. Okay, so now I can use my area formula because now I have a base and a height. So I have base times height by definition of the parallelogram. So it's going to be the square root of 5 times the square root of 45. Okay, so I'm going to let you type that in and tell me what you get. So square root of 5 times square root of 45. Okay, give me 3 decimals. 15 points. It's exactly 15. Oh, that's nice. 15. Okay, when you're dealing with area, I think that it's important for you to understand units. So since we don't technically have a measurement of inches or whatever it is, we're just going to use an increment of a unit. So we would say units squared. Okay, so it is important for you to measure area and label it correctly. Awesome? Awesome. Should we do one more?
Why not?
You want to do one more? So this one is kind of a crazy one that they drew out. This one actually is a little bit, this one's pretty nice. So this one is basically taking a kind of crazy shape and cutting it into little easy pieces. So for this one, what I see is I see a square. Do you see the square? That was a bad line. And, ooh, and a trapezoid and a triangle. Well, yeah, trapezoid, yeah. Yeah. So let's start with my little square. What's the area of the square? So it's got a base. I'm going to say area of the square. Base of 4. Height of 4. Obviously. So 16, all agreed. Okay, so then how about let's do this little triangle right here. This green triangle, which has a nice height, right? So I'm going to say area of my triangle. So 1/2 times the base, which is 4, times the height with it, which was 3. So I get 1/2 times 4, which is 2. 2 times 3 is 6. Do you guys like doing area of trapezoids or triangles?
Triangles.
So do I. But you could totally do, which color can I do? So I see this triangle, because it's a right triangle, and that's quite simple. So the area of my blue one would be 1/2 times the base, which is 2, and the height, which is 4. So 4. And then my last one, I'm running out of colors, gray. So that's this one. Oops, I erased that side. So my last one is going to be 1/2 times the base, which is 4, the height, which is 4. So 2 times 4 is 8. So add those all together. So what is 16 plus 6 plus 4, 26 plus 8? 26, 34, right? So then I would say units squared. How do you guys feel about perimeter and area? Awesome?
Solid.
Solid. I like solid.